Okay, we're going to look at moments, and we're going to go very briefly through it, but follow along and take some notes. So the key is first that a moment is caused by a force. A moment is caused by a force that makes a body rotate or spin around. Okay, so terminology, you have wherever it's spinning around is its pivot point. The distance to where the force is located, so if the force is right here, the distance perpendicular to the force, to the pivot, is the distance that you need. And then you have, of course, the force. Again, it's important that the distance has to be perpendicular to the force. So for the moment, the formula is m, moment, around, and sometimes we'll say like around pivot A, like if there's an A here. Around pivot A is equal to the force times the distance, and sometimes we even say the distance perpendicular. And this equation is on your formula sheet. You can find it there as well. The units, if in SI units, you're going to have Newton meters, and in English customary, you have foot pounds or pound feet. This is the key. There's a right-hand rule, but really, if the moment causes a counterclockwise rotation, it's positive. It's called a positive moment. And if it's clockwise, it's negative. Now, if you're wondering why it is, it seems a little backwards because a clock, right? The way I think of it is the sun rises in the east to the west, right? East to the west. Or you can also think of it if you think of math class, right? And you have angles, if you're in Algebra 2 or past, you always measure this way, and this is always your positive angle measurement is always going this way, right? That's 180 degrees going that way, okay? And this is like negative 45 degrees, for example, if you go this way, okay? It's negative 45. So that's one way to think of it, at least. Then they have the right-hand rules. You don't really need to worry about that, but you can look at that in more detail if you'd like. So we look at this wrench, and of course the work is all here already, but first I ask myself, which direction is this going to cause the thing to move, and it's clockwise, so it's negative. So it's a negative moment. And we have 9 inches, and we have 20 pounds, but we know that the unit should be foot-pounds, so we convert 9 inches into 0.75 feet, and we take negative, because it's clockwise, 20 pounds is the force, 0.75 feet, we multiply those, and we get negative 15 foot-pounds is our moment. Here's a longer wrench. So the force is the same. The force is still 20 pounds. And of course, the further away you are, the larger your moment will be. Now, if we look here, we obviously in this situation, if you notice, what would happen is the wrench would actually just slide off. But if this wrench was closed on here, if it was a closed end of a wrench, so it would stay on, some students might feel like pushing this way wouldn't cause any rotation, but it would. The key is that you no longer use this as your distance horizontally. And the reason you don't is because your distance, remember, for a moment, your force times your perpendicular distance. So if the force is going horizontally, the distance has to be vertical. So your distance is vertical, so your distance is 3 inches. And so you have negative, because it still causes a clockwise rotation, 20 pounds times 0.25 feet, which is 3 inches. And you get negative 5 foot-pounds for a moment. So how does equilibrium happen? Equilibrium happens if the sum of your moments equals 0, which means their object will not be rotating. And so the sum of the moments equals 0. So all your moments add up to equal 0, which of course that would mean that some of those moments would have to be negative. Okay? And so here's a seesaw calculation. We have 2 bears. And we're given the size of one bear to start, and we want to calculate how big does the other bear need to be in order to not cause rotation. And so this first bear is 25 pounds and 4 feet away. And he or she is going to cause a counterclockwise, which is positive moment. And this bear is, we don't know how far away. We want to know how far away does it need to be, but he weighs 40 pounds, so he weighs more, and he's causing a clockwise or negative rotation. So they've called this bear 1, and they've called this bear 2. As you can see here, you have moment 1 is positive, moment 2 is negative. And I always set up these equations like this. The sum of the moments equals 0. Moment 1 plus negative moment 2 equals 0. Then instead of plugging in numbers right now, they just went ahead and they moved this to the other side. So they said now moment 1 equals moment 2. Force 1 times distance 1 equals force 2 times distance 2. Plug in everything you know. 25 times 4 equals 40 times d2. Notice, not x. They didn't say x here, okay? Use the actual label. It's the distance of bear 2. And then you solve and you get 2.5 feet is how far away that bear needs to be. And that's reasonable because it's that bear is closer than number 1, which is reasonable because number 1 weighs less. And then you have another one here. You have 2 supports, and there's no horizontal forces, so we ignore any other supports, but we just say that there's a reaction force. This RB stands for a reaction at B, reaction force at B. And same thing for RA. And so this is 35 pounds down. And so we say, well, what are we rotating around? And what you'll notice is they said that B, so we select A as the pivot. So really, you should write here the sum of the moments around A is how I would write that. The sum of the moments around A equals 0. And then B is going to cause, if you look, a counterclockwise rotation, so that's positive. And C will cause clockwise rotation, so that's negative. And so they have negative moment at C plus moment at B equals 0. They went ahead and again and added this over. You don't have to add that over first. You could always just keep them together. Then they plug in these. Maybe you go to numbers right away. But again, RB is your variable times 10 feet away. This is 10 feet away from your pivot. Equals 35 pounds times 3 feet away. This is 3 feet away and 35 pounds. And then when you solve, you get RB equals 10.5 pounds. And you think you're done, and that's great. But then what's cool is you also know, so this right here, this part down here, I'm going to highlight it in green instead. This part down here, okay, what's cool about this is we know that the beam isn't moving down. So the sum of the forces in the y direction also equals 0. Right? And we know that there's a 35-pound force going down. So that means the force at A in the y direction plus the force at C in the y direction plus the force at B in the y direction all equals 0. We know that this force is negative 35. Right? That's the applied force here. Okay. We know that that force is negative 35. All right. We know that FBY, which we just found, RB is upward and is plus 10.5. And all these have to equal 0. So FAY, or what we could call it is just RA is what they call it, which is fine. So we should just say RA here. And these should just be RB and RA. And so RA, if we add those up and put them on the other side, is going to be 24.5 pounds. Because the downward is 35, and so the upward is here 10.5 and 24.5, which add up to 35. Here, what is the moment? Again, you have to convert these centimeters into meters, so it's 0.5 meters. And the horizontal distance with the vertical force, so 100 times 0.5 equals 50 Newton meters. It's positive because it's going counterclockwise, which is positive. And then here, what's interesting is the force is at an angle now. And so the y component of the force, you have to measure to the x-axis, right? And to find that, then you're going to do your F sine of 50. So the y component is only the 76.6. And so you do the 76.6 times the 0.5, and you get that. So if you don't pull straight down, if you pull off at an angle, you get less of a moment than if you pull straight down, which makes sense. And then you can go through the rest and look at these calculations as well. And then this one is very interesting. Lots of information in this one, but please do take a look at all the details of this one here and go through it. And then you can also watch the video on my trusses as well if you want to wait on this truss one. You can wait until trusses. Okay, and that's it for today.